Okay, we're talking about the combined gas law. That's when you combine Boyle's, Charles, and the Gay-Lussac's law, and then you get your combined gas law. So, the combined gas law takes the form P1 V1 T1 is equal to P2 V2 by T2. Okay, so what's being held constant is just the number of moles. Now, if you keep the temperature and moles constant, get rid of the temperature, you get Boyle's law. If you keep the pressure and moles constant, you'll end up with Charles' law. And then if you keep the volume and moles constant, you end up with Gay-Lussac's law, all right? So P1 V1 T1 is equal to P2 V2 T2. That's the combined gas law. All right, so here you have a problem using the combined gas law. The initial pressure is 646 millimeters of mercury, initial volume 675 mils, temperature is 308 K. P2 is 802 millimeters of mercury. You have to find out V2. The T2 is given minus 95, that's 178 K. All right. The best way to rearrange this equation is, again, opposites. P1 V1 times T2 is equal to P2 V2 times T1. And then you're solving for V2, which means you divide both sides by P2 T1. Okay. So V2 takes the form P1 V1 opposite temperature T2 divided by P2 T1. So 675 mils is V1, 646 millimeters of mercury is P1, T2 is 178 K, P2 is 802 millimeters of mercury, and T1 is 308 K. So get 314 mils is the answer. All right, sample of helium gas is a volume of 0.180 liters, pressure 0.8 atmosphere, temperature 29, and volume of 90 mil, and then the pressure is gone up to 3.20 atmosphere. Okay, so you have to find out T2. Okay, so see, write it in this form with opposite temperatures. Now you're solving for T2. So all you have to do is divide both sides by P1 V1. All right, so P2, that's 3.2 atmospheres, V2 is 90 mils, T1 is 302. Then you're going to divide this by 0.8 times the times 180 mil, and you should get T2. Okay, so you get your answer in Kelvin, subtract the 273, and then you get 331 degrees centigrade. All right, we'll stop here.